May 21, 1935, 11:47 a.m. Berlin-Hamburg Railway Line, Germany. The streamlined silver bullet screamed past the observation platform at 200 kilometers per hour, its aerodynamic profile blurring into motion. Reich Transport Minister Julius Dorpmüller stood watching, stopwatch in hand, as the Fliegender Hamburger, the Flying Hamburger, demonstrated what German engineering could achieve when freed from conventional limitations. Beside him, Franz Krukenberg, the train's designer, pointed to the speed indicator. 205 kilometers per hour, sustained. No theoretical maximum has yet been discovered. The diesel engines can maintain this indefinitely. Dorpmüller nodded slowly. Around them, Nazi officials murmured approval. Germany had the fastest regular passenger service in the world. The train completed the 286-kilometer journey between Berlin and Hamburg in 138 minutes. British trains averaged half that speed. Americans train less than that. But Hitler, watching from a distance, wasn't thinking about passengers. He was thinking about war, about moving troops and supplies faster than enemies could react, about trains that could outrun aircraft, that could evacuate critical personnel from bombed cities, that could transport V-weapons to launch sites before Allied intelligence could respond. What emerged from that observation would become one of the Third Reich's most ambitious and ultimately futile engineering projects, a supertrain designed to achieve speeds exceeding 200 kilometers per hour while carrying military cargo, a machine that would demonstrate German technological supremacy, a weapon that would revolutionize rail warfare. It would consume millions of Reichsmarks, employ thousands of engineers, require hundreds of kilometers of specially constructed track, and it would contribute absolutely nothing to Germany's war effort. Not one soldier was transported, not one weapon delivered, not one strategic objective achieved. This is the story of the Schienenzeppelin and its successors, Germany's high-speed rail projects that promised to change warfare and delivered only wasted resources at a time when every rivet, every liter of fuel, every engineer's hour was desperately needed elsewhere. The obsession with speed began long before the Nazis. German engineers had been pursuing high-speed rail since the 1890s, driven by a combination of technical curiosity and national pride. When electric traction enabled sustained high speeds, German rail companies competed to set records. By 1903, a modified electric rail car achieved 210 kilometers per hour, faster than any aircraft of the era. But these were experimental vehicles, not practical transportation. The real breakthrough came in 1930 when Franz Krukenberg, an engineer from Hamburg, proposed something revolutionary. Not an electric train bound to overhead catenary wires, but a diesel-powered rail vehicle using aircraft technology. Streamlined body, lightweight construction, aircraft engines. The concept was part train, part airplane, designed to slice through air resistance rather than force through it. His prototype, designated Schienenzeppelin, Rail Zeppelin, first ran in 1930. The vehicle was extraordinary to behold. 25 meters long, shaped like an aircraft fuselage laid on its side. The front tapered to a point, the rear mounted a massive four-blade propeller driven by a BMW VI aircraft engine producing 600 horsepower. The entire vehicle weighed only 20 tons, less than a conventional locomotive's tender. On June 21, 1931, on a test track between Hamburg and Berlin, the Schienenzeppelin achieved 230 kilometers per hour. The record would stand for 23 years. No rail vehicle would match it until 1954. German newspapers proclaimed it proof of engineering supremacy. Engineers worldwide studied the design. Railway companies expressed interest in commercial versions. Then reality intruded. The propeller created noise that made passenger service impractical. The vehicle could only push, not pull, limiting its cargo capacity. The lightweight construction couldn't handle the stresses of regular service. Most critically, it required dedicated track. Conventional rail traffic had to be halted for test runs. The Schienenzeppelin couldn't operate on shared lines without creating chaos. Krukenberg spent years trying to solve these problems. He proposed enclosed propellers, multiple unit configurations, hybrid systems using both propeller and conventional traction. Nothing worked economically. By 1934, the Schienenzeppelin was mothballed, an engineering curiosity that had achieved spectacular speed with no practical application. The Nazis saw it differently. When they took power in 1933, technology became ideology. German engineering wasn't just superior, it was proof of racial superiority. Every technical achievement validated Nazi beliefs about Aryan ingenuity. Every speed record demonstrated Germany's destiny to dominate. Hermann Göring, head of the Luftwaffe, and obsessed with anything involving speed and engines, visited Krukenberg's workshop in Hamburg in 1935. He examined the mothballed Schienenzeppelin, listened to Krukenberg's explanations of its potential, and immediately understood military applications nobody had previously considered. "Herr Krukenberg," Göring said, walking around the streamlined vehicle, "you have been thinking too small. This is not a passenger train. This is a weapon. Imagine evacuation trains that enemy bombers cannot catch, supply trains that deliver ammunition faster than enemies can reposition, fewer trains that could escape any ambush at speeds exceeding the fastest fighter aircraft." Krukenberg, eager for funding and Nazi approval, readily agreed. Within weeks, he received a contract from the Reich Transport Ministry to develop military applications of high-speed rail. The budget was substantial. The mandate was unlimited. Build trains that could outrun aircraft. The rest would follow. The project, designated Schnelltriebwagenprogramm, High-Speed Railcar Program, began operations in January 1936. Krukenberg assembled a team of engineers from aircraft companies, automotive manufacturers, and rail yards. The goal was to combine the speed of the Schienenzeppelin with the cargo capacity and reliability required for military use. The first challenge was propulsion. The propeller, while effective, was impractical for military operations. It created obvious noise that announced the train's approach kilometers in advance. It was vulnerable to sabotage. One well-placed obstruction and the propeller would disintegrate, destroying the vehicle. Most critically, it couldn't pull cargo cars. Everything had to be pushed. Krukenberg proposed an alternative: multiple diesel engines mounted in individual power cars, distributed throughout the train. Each power car would drive its own wheels through conventional traction. The train would be, in effect, multiple locomotives operating in coordinated fashion. The streamlined body would reduce air resistance. The distributed power would enable both pushing and pulling. The design that emerged was designated SVT-137, Schnelltriebwagen 137, High-Speed Railcar 137. Two power cars, each with 600 horsepower diesel engines. 3 passenger or cargo cars in between. Total capacity 140 passengers or 30 tons of military cargo. Design speed 180 kilometers per hour sustained, 200 kilometers per hour maximum. Construction began at Deutsche Reichsbahn workshops in Berlin in mid-1936. The vehicle used aircraft construction techniques: welded steel frame, aluminum body panels, streamlined profile with enclosed bogies and sealed doors. Every surface designed to minimize drag. The result looked more like a horizontal aircraft fuselage than a train. The first test runs in December 1936 immediately revealed problems. The distributed power system worked, but coordination between power cars was imperfect. One engine would pull slightly harder than the other, creating lateral forces that threatened derailment at high speed. The streamlining reduced drag but created aerodynamic lift at speeds above 160 kilometers per hour. The train wanted to fly. Engineers spent months refining the power control systems and adding aerodynamic modifications. By July 1937, the SVT-137 achieved 175 kilometers per hour sustained speed over a 50-kilometer test section. Fast, but not fast enough to satisfy Nazi expectations. Göring wanted 200 kilometers per hour minimum. Hitler had been told Germany would build trains faster than bombers. Anything less was failure. The solution was predictably German: more power. If 600 horsepower engines couldn't achieve the target, install 800 horsepower engines. If 2 power cars weren't sufficient, add a third. The modified design SVT-137B entered testing in early 1938 with 3 800 horsepower power cars and enhanced aerodynamics. On March 18, 1938, on a test track near Munich, the SVT-137B achieved 205 kilometers per hour. The newspapers proclaimed it the world's fastest train. Newsreels showed the silver streamliner blurring past cameras. Göring personally congratulated Krukenberg. The Führer was informed that German engineering had achieved the impossible. What the newsreels didn't show was what happened 15 kilometers down the track. At 205 kilometers per hour, a slight track irregularity caused the forward power car to oscillate. The oscillation amplified. Within seconds, the entire train was shaking violently. The engineer throttled back, but the oscillation continued. At 180 kilometers per hour, the rear power car derailed, dragging 3 cars off the track before the train ground to a halt. The damage was catastrophic. The rear power car was destroyed. 2 passenger cars were damaged beyond repair. The track was torn up for 200 meters. Miraculously, no one died, but several engineers were seriously injured. The 205 km/h run had lasted less than 2 minutes before mechanical physics destroyed the train. Investigation revealed the fundamental problem. The track couldn't handle the speeds. German railways used standard-gauge track designed for conventional trains traveling 120 km/h maximum. The rails, ties, and ballast weren't engineered for the dynamic forces created by 150-ton trains at 200 km/h. The vibrations that caused the derailment would occur on any conventional track at those speeds. The solution was obvious and impossible. Build dedicated high-speed track. Rails heavier than standard. Ties closer together. Ballast deeper. Curves gentler. Grades shallower. Every section engineered specifically for 200 km/h operations. The cost would be astronomical. The time required would be years. The construction would consume resources desperately needed for rearmament. Krukenberg presented the findings to the Reich Transport Ministry in April 1938. His report was precise. Sustained speeds above 180 km/h required completely new infrastructure. The existing rail network could not safely support the high-speed operations the military demanded. Building the necessary infrastructure would cost more than the entire railway budget. The bureaucratic response was predictably Nazi: ignore the problem and demand results anyway. The ministry informed Krukenberg that track limitations were unacceptable. German engineering would overcome these obstacles, continue development, achieve 200 km/h on existing track. Failure was not an option. So Krukenberg tried everything: softer suspensions to absorb track irregularities, active damping systems using hydraulics, lighter vehicles to reduce dynamic loads, aerodynamic modifications to reduce lift. Each solution solved one problem while creating others. Soft suspension reduced derailment risk but made the train unstable in crosswinds. Lightweight improved ride quality but limited cargo capacity. Active damping worked but required complex hydraulics that failed regularly. By late 1938, the program had consumed 12 million Reichsmarks and produced nothing deployable. The SVT-137 could achieve 180 kilometers per hour safely, but not the 200 required. Higher speeds on the existing track remained impossible without catastrophic derailment risk. The Schnelltriebwagen program was failing to deliver what Nazi leadership demanded. Then came the Anschluss with Austria and the occupation of Czechoslovakia. Suddenly, Germany's rail network expanded dramatically. New track, new routes, new strategic requirements, and new opportunities. The Austrian railways included several sections of newer, heavier track built in the 1920s. Perhaps these sections could support higher speeds without massive reconstruction. Testing began on Austrian track in November 1938. The results were marginally better. The SVT-137 achieved 190 km per hour sustained on the Vienna-Salzburg line. Still short of the 200-kilometer target, but close enough that Nazi propaganda declared victory anyway. Newsreels showed the train streaking through alpine scenery. The voiceover proclaimed Germany possessed the world's fastest military rail system. The military was less impressed. General Georg Thomas, head of War Economy and Armaments Office, examined the program in December 1938. His assessment was devastating. The high-speed trains offered no practical military advantage. They couldn't operate on most of Germany's rail network. They couldn't pull armored trains or heavy cargo. The specialized maintenance required meant they couldn't deploy to forward areas. And most critically, they were horrifically expensive. One high-speed train set cost as much as 50 conventional locomotives. Thomas recommended cancellation. The resources consumed by high-speed rail development would be better spent on conventional rolling stock, which Germany desperately needed for military mobilization. But his recommendation encountered the fundamental problem of Nazi governance. Hitler liked the idea. The Führer enjoyed bragging about German trains being faster than British bombers. Practical military utility was irrelevant compared to propaganda value. So the program continued into 1939, consuming resources while delivering nothing useful. Engineers built modified train sets. Test runs continued on select track sections. Propaganda films showcased German speed supremacy, and the military continued relying on conventional trains traveling 80 kilometers per hour because those were the only trains that worked reliably. September 1, 1939, Germany invaded Poland. World War II began. Suddenly, high-speed passenger trains became the lowest priority in the Reich Transport Ministry. Every locomotive, every freight car, every meter of track was needed for military logistics. Moving armies, weapons, and supplies consumed every available resource. The Schnelltriebwagen program was quietly suspended. Krukenberg and his engineers were reassigned to more pressing problems: how to increase conventional freight capacity, how to repair bombed rail yards, how to maintain aging locomotives with limited spare parts. The high-speed train sets sat in storage, expensive monuments to misplaced priorities. But the story didn't end there, because the Nazi regime never abandoned technological fantasies even when reality demanded focus on practical necessities. In 1941, with Germany fighting on multiple fronts, someone in the Reich Transport Ministry decided high-speed rail deserved another attempt. The justification was different this time, not passenger service or military transport, but something more specific: evacuating critical personnel and documents from bombed cities. Allied bombing was increasing. Government buildings in Berlin, Hamburg, and other cities faced destruction. High-speed trains could evacuate important people and materials before bombers arrived, moving them to safe locations faster than aircraft could follow. The project received new designation, Katastrophenzug, catastrophe train. Not officially, of course. Official documents called it Sonderzug A1, Special Train A1. But everyone involved used the more descriptive name. A train designed for escaping catastrophes, built by a regime that was rapidly becoming one. Development restarted in early 1942 under even more stringent constraints. Steel was allocated for weapons, not passenger trains. Aluminum was reserved for aircraft. Diesel fuel was desperately needed by the military. Every material the Katastrophenzug required was needed elsewhere more urgently. The engineers adapted. Instead of building new train sets, they modified existing SVT vehicles. Instead of aluminum bodies, they used steel. Instead of powerful engines, they used whatever was available. The resulting vehicles were heavier, slower, less efficient versions of the already inadequate pre-war designs. Test runs resumed in March 1942 on the same Austrian track that had supported 190 kilometers per hour in 1938. The modified vehicles achieved 160 kilometers per hour, adequate for evacuations, but nowhere near the speeds originally promised. More importantly, they still couldn't operate safely on most German track. The fundamental problems remained. High speeds required special track. Special track required massive construction. Construction required resources Germany didn't have. The circle was unbreakable. Meanwhile, the military situation deteriorated. The Battle of Stalingrad, the North Africa campaign is collapsing. Allied bombing is intensifying. The Reich needed conventional transport desperately. Every standard freight car mattered. Every normal locomotive was critical. And the high-speed rail program was consuming skilled labor and materials while contributing nothing. In July 1942, Albert Speer, recently appointed armaments minister, reviewed all transportation projects. His assessment of the high-speed rail program was brutal. We are attempting to build racing cars when what we need are trucks. This program will be terminated immediately. All personnel reassigned to conventional rolling stock production. All materials redirected to military priorities. The order was clear. The Katastrophenzug program ended officially on August 15, 1942. The train sets were mothballed. The engineers dispersed to other projects. The special Trek sections were returned to conventional use. Germany's high-speed rail ambitions died not with dramatic failure, but quiet cancellation, recognized finally as the waste they had always been. Total expenditure? 27 million Reichsmarks between 1936 and 1942, enough to build 540 conventional locomotives or 8,100 freight cars. The military utility delivered? Zero. The strategic impact? None. The propaganda value? Minimal, since by 1942, nobody cared about train speed records while cities were being bombed flat. But the story still wasn't finished, because even after official cancellation, the high-speed train sets continued to exist. They sat in rail yards, expensive and useless. And in the chaos of 1943 and 1944, various Nazi officials occasionally remembered they existed and proposed new uses for them. In March 1943, Heinrich Himmler, head of the SS, suggested using the high-speed trains to transport concentration camp labor to industrial sites. The proposal went nowhere because the trains couldn't operate where the camps and factories were located. In June 1943, Joseph Goebbels proposed using them for a rapid courier service between Hitler's various headquarters. The proposal failed because the Führer refused to ride in them, considering them unsafe. In November 1943, someone suggested converting them to armored trains. Engineers examined the possibility and determined that the lightweight construction couldn't support armor. The vehicles would need complete reconstruction, which would cost more than building conventional armored trains. In January 1944, another proposal suggested using them as mobile command posts. This failed because mobile command posts needed to go where battles were, and battles weren't occurring on the specific track sections where high-speed trains could operate. Each proposal wasted time studying options that careful analysis would have immediately revealed were impossible. But this was characteristic of Nazi governance in the war's final years. Desperate searching for technological solutions to strategic problems that technology couldn't solve. The high-speed train sets survived into 1944 mostly through bureaucratic inertia. Nobody wanted them, but nobody bothered to scrap them. They sat in rail yards in Vienna, Munich, and Berlin, occasionally moved to clear space, sometimes damaged by bombing, and gradually deteriorated from lack of maintenance. In July 1944, after the failed assassination attempt on Hitler, one of the high-speed train sets was prepared as an emergency escape vehicle for the Nazi leadership. The logic was that if the coup had succeeded, senior officials could escape to Bavaria at speeds bombers couldn't match. The train set sat ready, crew assigned, route prepared. Nobody used it. The coup failed. The train set returned to storage. By late 1944, Allied bombing had destroyed much of Germany's rail infrastructure. The special track sections that had supported high-speed operations were priority targets because their heavy construction made them important for military transport. The Vienna-Salzburg line was bombed repeatedly. The Munich test track was destroyed in August 1944. The remaining sections were damaged so extensively that even conventional trains couldn't use them. The high-speed train sets, designed to outrun bombers, sat immobile while Allied aircraft destroyed the infrastructure they required. The irony was not lost on the engineers. They had built trains too fast for German rails, but too slow to escape the strategic bombing that made all rail operations increasingly impossible. In January 1945, with Soviet forces approaching from the east and Allied forces from the west, someone ordered the high-speed train sets evacuated to prevent capture. 3 vehicles departed Vienna, heading west. They managed approximately 120 kilometers before the damaged track forced them to halt. The crews abandoned them. Soviet forces found them weeks later, studied them briefly, and scrapped them. The technology was interesting, but irrelevant to armies using horses for logistics because fuel was unavailable for trucks. The remaining train sets were destroyed in various ways. One burned in the Munich rail yard during a bombing raid, another was deliberately blown up by retreating German forces to prevent capture. A third was abandoned in Berlin and subsequently scrapped by occupation forces. None survived the war intact. Franz Krukenberg survived. He was interrogated by American investigators in 1945 about Germany's high-speed rail programs. His testimony was matter-of-fact. The trains worked as engineering demonstrations. They failed as a practical transportation. The program consumed resources that should have been used elsewhere. He expressed no regrets about the engineering, but acknowledged the strategic waste. American investigators were more interested in the technology than the strategic failure. Could the trains have worked with proper infrastructure? Absolutely. Were they technically impressive? Certainly. Did they represent good engineering? Yes. Were they completely inappropriate for wartime Germany? Obviously. The Americans examined captured documents detailing the program. The files showed a steady escalation of costs combined with a steady reduction of capabilities. Each year, the trains got slower, heavier, and less capable, while becoming more expensive. Each modification added weight while solving problems created by previous modifications. The engineering had been trapped in a cycle of diminishing returns from the beginning. The final assessment was damning. The German high-speed rail program represents engineering excellence applied to strategically irrelevant objectives. The technical achievements are noteworthy. The military utility is non-existent. The resource expenditure is unconscionable given Germany's wartime constraints. This program exemplifies the Third Reich's tendency to pursue prestige projects at the expense of practical necessity. After the war, the high-speed rail technology didn't disappear. The engineering concepts were sound. The aerodynamic principles were correct. The propulsion systems worked. But practical high-speed rail required infrastructure investment that made sense only in peacetime, in wealthy nations with strong economies. Post-war Germany, divided and devastated, couldn't afford such luxuries. The first successful high-speed rail network appeared in Japan in 1964. The Shinkansen achieved 210 kilometers per hour, barely faster than Germany's 1931 Schienenzeppelin, but it achieved this speed safely, reliably, and profitably. The difference wasn't technology. The difference was infrastructure. Japan built dedicated track from scratch, designed specifically for high-speed operations. The track cost more than the trains, but without proper track, the trains were useless, as Germany had learned. Europe followed in the 1980s. The French TGV, German ICE, Spanish AVE, and Italian ETR trains all achieved speeds Germany had attempted in the 1930s. But these programs cost billions and required decades. They succeeded because wealthy, peaceful nations could afford the massive infrastructure investment. Germany in the 1930s and 1940s, preparing for war and then fighting one, could afford no such luxury. The historical lesson is straightforward but often ignored. Technical capability doesn't ensure practical utility. Germany could build trains capable of 200 kilometers per hour in 1938, but Germany couldn't build the infrastructure those trains required. Without infrastructure, the capability was worthless. With the war beginning, the entire program became an expensive distraction from real military needs. The resources consumed by the Schnelltreibwagen program between 1936 and 1942 would have built 540 conventional locomotives or 8,100 freight cars. Those locomotives and freight cars might not have won the war for Germany. The strategic situation by 1942 made German victory unlikely regardless, but they would have significantly eased the logistics crisis that hampered military operations throughout the war. Instead, Germany built trains that were too fast for their own track, too specialized for military use, too expensive for wartime production, and too limited in application to contribute meaningfully to any strategic objective. The program consumed resources while delivering nothing except propaganda footage and engineering data that would prove useful to other nations decades later. The Nazi Supertrain that could outrun bombers was real. The engineering was sound. The speeds were achievable. But the strategic context made the entire program pointless from the beginning. Germany needed trains that worked, not trains that broke records. The difference between those two needs was vast, and the regime's failure to recognize that difference wasted resources at precisely the time when waste was least affordable. In 1985, a German railway historian examining the Schnelltreibwagen program files wrote, "This program demonstrates the Third Reich's fundamental confusion between capability and utility. They built machines that could achieve impressive speeds but couldn't go anywhere that mattered. They pursued records rather than results. They valued propaganda over practicality. The high-speed trains were technological marvels that contributed nothing to Germany's war effort because marvels weren't what the war required." The mathematics were simple. 27 million Reichsmarks produced trains that completed 0 military missions. That same investment in conventional equipment would have completed millions. The return on investment was literally 0.
no other way to calculate it. The program failed absolutely to deliver any military value while consuming resources desperately needed elsewhere.
Today, fragments of the story survive in archives. Design documents showing beautiful, streamlined trains, test results proving they could achieve the promised speeds, photographs of silver vehicles streaking through the German countryside, financial records documenting the steadily increasing costs, military assessments explaining why the trains were useless. All of it preserved, a complete record of expensive failure. The irony is that Germany today operates some of the world's best high-speed rail. The ICE trains achieve 300 kilometers per hour, far faster than the 1930s designs. They operate profitably, carrying millions of passengers annually. They work because post-war Germany built the infrastructure the technology required. The 1930s program failed because Nazi Germany couldn't. The final word belongs to General George Thomas, who tried to cancel the program in 1938. In his post-war memoirs, he wrote about the high-speed trains, "I told them repeatedly that we needed practical transportation, not impressive speed records. I showed them calculations proving the program would deliver no military benefit. I demonstrated that the resources could be better used elsewhere. They ignored everything. The Führer liked fast trains, so we built fast trains, regardless of whether they served any purpose. This is how the Reich made decisions. This is why we lost." The Nazi Supertrain promised to revolutionize warfare. It promised to outrun bombers and evacuate cities and transport troops faster than enemies could react. It delivered nothing except expensive machinery that couldn't operate where it was needed and wasn't needed where it could operate. They said it would change war. They said German engineering would overcome all obstacles. They said speed would provide strategic advantage. They were wrong about everything except the speed. The trains were fast, but fast was useless without track, and track required resources Germany didn't have while fighting a war it was losing. The Supertrain went nowhere because nowhere was where it could go. The tracks that could support it barely existed, the places that needed it were unreachable, the missions it could perform didn't matter. It was the wrong machine for the wrong war, built by a regime that valued spectacle over practicality. 27 million Reichsmarks, 7 years of development, thousands of engineering hours, 0 military contributions. That was the final accounting of Germany's high-speed rail ambitions. Not dramatic failure, but quiet irrelevance. Not catastrophic defeat, but expensive waste. In the end, the Nazi Supertrain became what it had always been, an impressive demonstration of technical capability applied to strategically meaningless objectives. Germany could build trains faster than bombers, but Germany needed trains that could carry freight reliably on damaged track, not trains that could set speed records on perfect routes that didn't exist. The difference between those two needs was the difference between engineering fantasy and military reality. The Nazis chose fantasy. The trains went nowhere, and Germany lost the war while the silver streamliners sat in rail yards, monuments to the regime's fundamental inability to distinguish between impressive and useful. They built the train that could outrun bombers. It achieved the speeds they promised, and it contributed absolutely nothing to anything that mattered. Perfect engineering, complete strategic failure. The story of Nazi Germany in one expensive, useless machine. The Americans who examined the remnants in 1945 found the irony inescapable. In storage facilities across southern Germany, they discovered not just the high-speed train sets, but complete documentation of the program. Every design iteration, every test result, every cost overrun, every bureaucratic justification for continuing a project that delivered nothing.
Lieutenant Colonel Robert Hayes, a railway engineer assigned to investigate German transportation systems, spent 3 weeks reviewing the files. His report to the War Department included a section that would be quoted in military logistics textbooks for decades. The Germans built trains capable of 200 kilometers per hour while their army was using horses. They invested in experimental rail cars while conventional locomotives sat unrepaired. They pursued speed records while their supply system collapsed. This represents a fundamental failure to understand that war is won by logistics, not by technology demonstrations. The contrast with Allied transportation efforts was stark. Britain and America built nothing comparable to Germany's high-speed trains. British rail development during the war focused entirely on increasing freight capacity. American locomotive production emphasized standardization and reliability. Neither nation attempted speed records or experimental designs. Both prioritized boring, practical improvements that maximized cargo delivery. The results spoke for themselves. By 1944, Allied logistics were overwhelming. American and British forces moved millions of tons of supplies over thousands of kilometers. The transportation system worked not because it was impressive, but because it was adequate and vast. Conventional trains traveling conventional speeds on conventional track multiplied until the sheer volume became unstoppable. Germany's logistics, meanwhile, were collapsing, not from lack of engineering skill, but from lack of practical focus. Resources spent on experimental high-speed trains weren't available for conventional rolling stock. Engineers assigned to aerodynamic optimization couldn't repair damaged locomotives. Every Reichsmark invested in prestige projects was unavailable for practical necessities. The Snell Triebwagen program was just one example among many. Germany also developed experimental propeller-driven tanks, flying platforms for infantry, sound cannons, wind cannons, sun guns, and numerous other projects that consumed resources while delivering nothing useful. Each project demonstrated technical ingenuity. Each project wasted materials and manpower that conventional weapons programs needed desperately. This pattern reflected something fundamental about Nazi governance. The regime valued spectacle over substance. Projects that sounded impressive received funding regardless of practical utility. Hitler personally approved programs that excited his imagination while ignoring mundane but critical infrastructure needs. Goering championed any technology involving speed or power, regardless of strategic relevance.
The high-speed trains excited the Nazi leadership because they seemed futuristic and powerful. Trains faster than bombers sounded like victory. The practical details, where these trains would operate, what they would carry, how they would be maintained, and whether they would provide actual military advantage, received minimal consideration. The concept was approved. The execution was assumed. The utility was never properly questioned. This approach worked adequately in peacetime, when resources were plentiful and failures could be written off. It became catastrophic in war when every wasted resource contributed to defeat. By 1942, Germany was fighting the Soviet Union, Britain, and America simultaneously. Material constraints were absolute. Every ton of steel had competing demands. Every engineer had multiple urgent projects. Every liter of fuel was desperately needed. In this environment, the high-speed rail program should have been canceled immediately. The strategic case against it was overwhelming. But cancellation required admitting the program had been a mistake from the beginning. It required acknowledging that the Führer's enthusiasm for fast trains had led to wasted investment. Nazi governance made such admissions nearly impossible. So the program continued in zombie form through 1942, consuming fewer resources than before, but still consuming resources.
Engineers worked on modifications nobody needed. Test runs occurred on track sections increasingly damaged by bombing. Reports circulated claiming progress toward objectives that no longer mattered. The bureaucratic momentum carried the project forward months after any rational analysis would have killed it. When Speer finally canceled the program in August 1942, his order was framed as a temporary suspension, not permanent termination. The official language spoke of redirecting resources to more immediate priorities while maintaining the option to resume development later. This face-saving formulation allowed cancellation without admitting failure. The high-speed trains weren't abandoned, they were merely postponed. Of course, they were never resumed. By late 1942, Germany's strategic position made experimental transportation programs absurd luxuries. The Battle of Stalingrad was consuming an entire army. The North Africa campaign was collapsing. Allied bombing was intensifying. The very idea of developing 200-kilometer-per-hour passenger trains while armies lacked basic supplies was manifestly insane. But the train sets remained, physical artifacts of wasted resources. Some were eventually scrapped for materials. Others sat unused until destroyed by bombing or captured by advancing forces. A few survived into the occupation period, examined by Allied investigators, and then broken up. None served any purpose after 1942 except as evidence of strategic incompetence. The engineers who worked on the program had mixed feelings about their involvement. Some were proud of the technical achievements, regardless of strategic failure. They had solved difficult engineering problems and pushed the boundaries of what rail technology could achieve. The fact that these achievements proved militarily useless didn't diminish the engineering accomplishment in their minds. Others recognized the program as the waste it was and felt complicit in Germany's defeat. They had worked on impressive machines while the nation needed unglamorous reliability. Their skills had been misapplied at a critical time. The opportunity cost of their work, what they could have accomplished if assigned to practical projects, haunted them after the war. Franz Krukenberg fell into the first category. In post-war interviews, he defended the program's technical merits while acknowledging its strategic irrelevance. "We built trains that could achieve 205 kilometers per hour safely and reliably," he said in a 1956 interview. That the trains couldn't go anywhere that mattered was not an engineering failure, that was a strategic failure. "We were told to build fast trains. We built fast trains. If they were the wrong trains, that's not our fault." This distinction between technical success and strategic failure was common among German engineers after the war. They had accomplished impressive feats within their narrow domains while the broader strategic picture fell apart. Whether this absolved them of responsibility remained debatable. They followed orders and produced the requested results. That the orders were foolish and the results were useless wasn't their decision. The broader lesson was that technical excellence doesn't compensate for strategic blindness. Germany had arguably the best engineers in the world in the 1930s and 1940s. German technical achievements during this period were extraordinary across multiple domains. But a technical achievement disconnected from strategic necessity was worthless in war. The Allies understood this intuitively. British and American weapons programs prioritized practical utility over technical sophistication. When faced with choices between impressive designs and adequate designs that could be produced in quantity, Allied planners consistently chose quantity. The Sherman tank was inferior to German Panthers in direct combat, but America built 50,000 Shermans. The Panther was technically superior, but Germany built 6,000. Quantity prevailed. The same logic applies to transportation. Conventional trains were boring and slow compared to high-speed experimental designs. But conventional trains worked everywhere, carried everything and could be built in the thousands. High-speed trains were exciting and fast, and completely impractical for wartime logistics. The choice should have been obvious. Germany chose wrong. This pattern repeated across German war production. Jets instead of more conventional fighters, V-weapons instead of more artillery, giant tanks instead of more medium tanks, experimental submarines instead of more conventional U-boats. Each program demonstrated technical prowess while consuming resources that practical alternatives would have used more effectively. The cumulative effect was significant. Not decisive, Germany would have lost the war regardless of better resource allocation, but significant. The material and manpower consumed by experimental programs between 1939 and 1945 represented a substantial fraction of Germany's total war production. Redirected to conventional weapons and equipment, these resources would have extended Germany's capacity to resist, though not change the outcome.
The high-speed rail program's contribution to this waste was modest compared to programs like the V-weapons or jet fighters. 27 million Reichsmarks was substantial, but not enormous in the context of total war expenditure. The broader significance was what the program revealed about Nazi decision-making and priority setting. A rational military power faced with Germany's strategic situation in 1936 to 1942 would never have invested in high-speed passenger trains. The military utility was obviously zero. The resource consumption was clearly excessive. The opportunity cost was manifestly high. The decision to proceed revealed that Nazi Germany was not a rational military power. Instead, Nazi Germany was a regime that made decisions based on the Führer's preferences, powerful individuals' pet projects, and ideological imperatives that had nothing to do with military effectiveness. High-speed trains proceeded because Hitler liked the idea, Göring championed it, and it demonstrated German technological supremacy. These factors outweighed practical military considerations. This decision-making process characterized Nazi governance across domains. Racial ideology determined military strategy in the East, leading to catastrophic policies that turned potential allies into desperate enemies. Personal rivalries between Nazi leaders created competing bureaucracies that wasted resources through duplication and conflict. The Führer's architectural ambitions diverted construction materials to prestige buildings, while fortifications went unbuilt. The high-speed trains were a minor example of this dysfunction, but a representative one. The program demonstrated in miniature everything wrong with Nazi strategic planning: pursuit of impressive but useless capabilities, inability to admit mistakes and cancel failed programs, prioritization of propaganda over practical military utility, and fundamental confusion between technical achievement and strategic advantage. After the war, military analysts studied German programs to understand what went wrong. The consensus was that Germany had lost not because of inadequate technology, but because of inadequate strategic focus. German weapons were often superior to Allied equivalents. German engineering was frequently more sophisticated. But Germany built the wrong things in the wrong quantities at the wrong times. The high-speed trains exemplified this. Germany built trains that could achieve impressive speeds, but couldn't contribute to military logistics. The engineering was excellent, the strategic thinking was catastrophic, and the resources consumed would have been far more valuable if applied to mundane but necessary transportation improvements. One statistic captured the program's futility perfectly. The Schnelltriebwagen program consumed enough resources to build 540 conventional locomotives. Those locomotives, if built, would have hauled approximately 27,000 trains during the war. Those trains would have moved roughly 5.4 million tons of military cargo.
Instead, Germany built experimental high-speed train sets that moved 0 tons of military cargo because they couldn't operate on the network where cargo needed to move. The opportunity cost was staggering, not enough to change the war's outcome, but enough to matter. 5 million tons of cargo was equivalent to the supply requirements of 10 divisions for a year, or the fuel needs of the Luftwaffe for 6 months, or the ammunition consumption of the Eastern Front for 3 months. Resources that could have extended German capacity to resist were instead invested in machines that contributed nothing. This was the true cost of the Nazi Supertrain, not just the money wasted or the materials consumed, but the practical military capability sacrificed to build impressive machines that served no purpose. Germany chose spectacle over substance and paid the price in reduced military effectiveness when effectiveness mattered most. By 1943, reality had imposed itself so thoroughly that even Nazi leadership couldn't deny it. The high-speed trains sat abandoned while conventional logistics collapsed. Engineers who had designed experimental rail cars were reassigned to repair damaged track. Test facilities were converted to manufacture spare parts for aging locomotives. The dream of trains faster than bombers was forgotten as Germany struggled to move supplies on rail, being systematically destroyed by those bombers. The final indignity came in 1944 when the special high-speed track sections became priority bombing targets. Allied planners identified these sections as important rail corridors based on their heavy construction. They didn't know the track had been built for experimental high-speed operations. They just saw well-built rail lines and bombed them. The infrastructure Germany had built for trains that could outrun bombers was destroyed by bombers that those trains had never outrun. The symbolism was perfect. Germany had invested in specialized infrastructure for experimental trains that never operated militarily. Then the infrastructure was destroyed by enemy aircraft. The trains were supposedly designed to evade. The entire concept, build trains faster than bombers so they could escape bombing, had been invalidated by the reality that bombers didn't need to chase trains. They could destroy the tracks instead. This hadn't occurred to German planners in 1936 when the program began. They envisioned fast trains outrunning aircraft, not recognizing that aircraft could target infrastructure rather than moving trains. The failure to anticipate this reflected the program's fundamental strategic blindness. The scenarios justifying high-speed trains were fantasies disconnected from how air power actually worked. By May 1945, the program's failure was complete and absolute. Every high-speed train set was destroyed or abandoned. Every kilometer of special track was damaged or destroyed. Every resource invested had produced zero military benefit. The program had consumed 6 years of work and substantial funding while contributing nothing to Germany's war effort except propaganda footage that looked increasingly absurd as the war progressed. The final assessment was written not by Germans but by American investigators. Their report to the War Department concluded, "The German high-speed rail program represents one of numerous examples of technically proficient engineering applied to strategically irrelevant objectives. The trains achieved the promised speeds, the technology was sound, the execution was competent, but the entire program was unnecessary and wasteful from a military perspective. Germany would have been better served by investing these resources in conventional equipment that addressed actual logistical needs rather than experimental systems that addressed no real military requirement." This assessment became the standard historical judgment. The Schnelltreibwagen program was a well-executed solution to a problem that didn't exist, built during a period when real problems desperately needed solutions. It was impressive engineering, wasted on pointless objectives, while practical necessities went unaddressed. The lesson extended beyond trains. Germany's weapons development throughout the war period showed similar patterns. Impressive technical achievements, sophisticated engineering, advanced designs, and frequent disconnection from strategic necessities. Resources invested in wonder weapons would have been more valuable if invested in conventional weapons produced in quantity. But Nazi ideology rejected this logic. The regime believed in German technical superiority as proof of racial superiority. Building weapons that were merely adequate seemed defeatist. Germany needed weapons that demonstrated Aryan genius. This thinking produced spectacular engineering achievements that contributed minimally to military effectiveness. The high-speed trains were among the least harmful examples. Programs like the V-weapons consumed vastly more resources while delivering even less military value. But the trains exemplified the mindset that produced these programs, the belief that technical sophistication could compensate for strategic disadvantage, that impressive machines could overcome material inferiority, that German engineering would find paths to victory that conventional analysis said didn't exist. These beliefs were comforting fantasies. They allowed Nazi leadership to avoid confronting Germany's actual strategic position, fighting enemies with greater resources, larger populations, and sufficient technical capability to match German sophistication where it actually mattered. No amount of experimental trains or wonder weapons could overcome these fundamental disadvantages. The supertrain that could outrun bombers went nowhere because Germany was going nowhere. The regime had started a war it couldn't win against enemies it couldn't defeat. Technical achievements like high-speed trains were impressive distractions from this reality. They demonstrated what German engineering could accomplish while Germany was losing. In the end, the Nazi Supertrain's legacy was serving as a historical footnote illustrating misallocated resources and strategic confusion. The technology eventually influenced post-war high-speed rail development, but that influence came decades later in peacetime contexts where massive infrastructure investment made sense. During the war, when Germany built the trains, they were expensive, irrelevant, that consumed resources without contributing to survival. The mathematics remained brutal. 27 million Reichsmarks, 7 years of development, 0 military value delivered. Perfect engineering, complete strategic failure. A train that could outrun bombers but went nowhere because nowhere was where it could go and nowhere was where it mattered. They promised revolution. They delivered expensive machinery that couldn't operate where needed. They claimed a strategic advantage. They created propaganda footage and nothing else. They said speed would change warfare. Speed changed nothing because the trains couldn't reach the war. The Nazi Supertrain sat in storage while Germany lost. It survived initial victories and watched defeats. It remained pristine while the nation burned. And when defeat came finally in 1945, the trains were scrapped or captured, their metal recycled, their technology studied, their strategic impact exactly 0.
The last word belongs to the statistics. Germany built experimental trains that achieved 205 kilometers per hour. Germany lost 3.5 million military personnel. The trains transported none of them. Germany consumed 340 million tons of strategic materials. The trains moved none of it. Germany fought on 3 continents across 6 years. The trains contributed nothing to any campaign. Fast trains that went nowhere, expensive machines that did nothing, technical marvels that mattered not at all. The Nazi Supertrain in 3 simple descriptions: impressive, useless, forgotten. The thunder had promised speed. The speed went nowhere.
And Germany learned that going nowhere quickly doesn't matter when you need to go somewhere that matters. The Supertrain demonstrated this lesson at the cost of millions of Reichsmarks Germany couldn't spare while fighting a war it couldn't win. They built the train. It went nowhere. Germany followed.